Now let's look at how dbcontext keeps track of an entity. An entity is tracked once EF-Core has had some reason to create a tracking object for it. You've seen that one of those reasons is when it's tracking the results of a query. The state property of entity entry has a set of enums. The default state is unchanged, which represents when the context first became aware of the entity. In other words, since we met, nothing has changed. There are other actions that will trigger a dbcontext to begin tracking an entity or change its state to one of the other enums, added, modified, or deleted. You got a quick look at save changes in the first module. When your code calls save changes, the dbcontext takes one last look at the entities that you're saving to see if their state information needs to be modified, such as the state enum or the current values. With that info in hand, EF-Core uses the state enum to see if it needs to perform an insert, an update, or a delete in the database. Then it reads the current values and original values from the entity entry and uses its knowledge of how the entity and its properties map to the database table and columns. And with the help of the database provider, it then is able to determine the SQL command that needs to go to the database. Once the SQL is created, it then uses the provider's information and the connection string that you define opens a connection to the database and sends the SQL command that it built. When the database is finished, it'll return a little bit of information back to EF-Core. First, it will let it know the number of records that were affected. And additionally, if you inserted any new rows and the database generated keys for those rows, it will return those key values to the dbcontext. Then, if needed, the dbcontext will update the entity's keys and foreign keys to the values created by the database. The last task is to modify the entity entry objects for any of the entities that were sent to the database, resetting their state back to unchanged and their original values to whatever they are now. You've seen me create and insert data into the database a few times. Let's look a bit more closely at that. The most common way to add an object is to use the dbSetAdd method, which is something we've done a few times already. And this is one of those triggers that lets the context be aware of the object. At the same time, because you use the add method, the context sets its state, that is, the state property of the entity entry object, to added. The dbcontext itself also has an add method that's useful in particular scenarios. For example, if you're writing generic code, which may not know which dbSet you're working with. In that case, when you pass the object into dbcontext_add, the context will figure out what the type is so that it can create the tracking object with the proper information. There are a few other ways to add data to the context, but they're not relevant to this point in your education. Here I'm creating a new author object, and notice I'm not providing a value for ID because I know the database is going to be doing that for me. When I run this and call add, the ID is still 0. Now let's call save changes. EF-Core sees that the state is added and constructs a T-SQL insert statement with all of the property values except for the ID. Because by default, EF-Core knows the database will be generating those keys, it doesn't need to and shouldn't push those temporary values into the database. And the insert statement is parameterized. The first name and last name were sent in as parameters. All insert, update, and delete commands generated by EF-Core will always be parameterized. But notice something else interesting about the SQL statement. It's not just an insert, but it has a query at the end. The query is asking for the ID value that the database just created for this author row. Here's the new row in the database, and its ID is 14. That value gets sent back to EF-Core, which then pushes it into the ID property of the author. And look, the author's ID is also 14. By the way, because this dbcontext is still in scope, the dbcontext is still tracking this author. So after it finished executing the command, it fixed up the change tracking object with a new ID value and also reset its state. It's now unchanged. And this is important. If you were to call Save Changes again, you would not want EF-Core to try to insert that author a second time. But with its state unchanged, Save Changes will just ignore that entity. The DB context gets disposed along with the tracking objects. So in this particular case, we don't really benefit from that fix-up. Now you'll get to do something new, updating data that's already been stored in the database. Remember when I inserted 2 Julie Lermans? One of me is enough. So I'm going to edit one of those rows and change it to my fancy name, Julia. Julie is my nickname, but Julia is what's on my birth certificate. And for what it's worth, I have been asked so many times how Julie can be a nickname for Julia because it's the same number of letters. But who's counting letters? It's less syllables, so a big time saver, right? Anyway, how to go about fixing that? I'll use EF-Core to query the database for the first one of the Julie Lermans. And to be sure I'm getting the right data, I'll filter on the first and last name. Then I do a null check to make sure I did get back some data, and I'll set the first name to Julia and call Save Changes. Notice I didn't use an add or update method here, although it's true there is an update command, which you'll be learning about later. But here, the context is still tracking that author, so when I call Save Changes, it does that quick check of the author values and notices that something has changed. So it sets the state to modified, and then Save Changes knows to build an update command. When we look at what happened in the database, first we see the query to get that row of data. And remember, since I used the link first or default method, that turns into a select top 1 query. Then you can see the second command sent to the database, the update command. And it's saying to set the author name to Julia where the author's ID is 1. And as expected, the update command is parameterized. The ID and the new value of first name were sent in as parameters. There's also an extra command in here, select row count. The update command will return the number of rows affected to EF-Core. And in fact, the Save Changes method itself returns an integer representing the number of rows affected by Save Changes. But if we look back at the insert command, it didn't return a row count. That's because you can only insert 1 row at a time, so Save Changes will count that as 1. And even though in our particular case, we're only updating 1 row, it's possible that I may have sent an update that affected a number of rows. So Save Changes does rely on this row count coming back from the database. I'm not capturing that value, however, so let's move on to another update. Here I'm retrieving and updating a number of authors. People often misspell my last name. They like to put an H in there. So clearly, this method was written by one of those people. It will query for all the authors whose last name is Lerman with the proper spelling. Then it iterates through the results and changes each author's last name to Lehrman, and then calls Save Changes. So again, the context was still tracking these authors when the edit was made, and therefore Save Changes triggers 3 updates to go to the database. Notice that they're sent as 3 separate commands. That won't always be the case, but that's definitely what I expected in this scenario. First, it's updating the author whose ID is 1. Next, the author whose ID is 3. And finally, the author whose ID is 4. And for each one, the row count, 1, is being sent back to EF-Core, and it will add all of those up, and if I did ask for the result of Save Changes, it would be 3. Now, of course, I'm not happy that the database has mine and my mom's last names misspelled. So I've modified the method to look for all of those Lehrmans and change them back to the correct spelling. But while I'm doing this, I'll show you another interesting and useful feature of how the DB Context Change Tracker is learning about these changes. Remember that the context is not managing the entities directly. And I have said a few times that when you call Save Changes, the context will take one last look at the objects to determine their state and property values. And the way it does that is with a method called Detect Changes. Detect Changes reads the values of all the entities it's tracking and updates the state details in the tracking objects being managed by the change tracker. Save Changes calls Detect Changes as part of its process. Detect Changes is not an internal method. You can call it yourself if you have a need. And I'm going to do that because I have a need to teach you. I'm also taking advantage of a cool feature that arrived in EF Core 6 called the Debug View. The short view is all we need. There's also a long view, which has a deeper level of details. So after I edit the last names, I'll use the debug view to show you what the context knows about the authors. Remember that the context queried those authors, so it is aware of them. Then I will call Detect Changes explicitly, and after that, once again, we'll see what the context knows about the author entities afterwards. I'll put a breakpoint just before I call Detect Changes. Here we go. And before Detect Changes is hit, the context says it's tracking 3 objects. Each one is an author type. Their IDs are 1, 3, and 4, and the state of each one is unchanged. So the context is not yet aware of the changes. Now I'll call Detect Changes, and this time the output of Debug View shows that the state of each of our authors is now modified. Save Changes will still call Detect Changes again internally because that's what it does, but the information will be no different. And then when EF Core builds the SQL, everything it needs to know is in the change tracker entity entries. It knows the authors are modified and it's aware of their values. I think it's really helpful to understand that while the DB context is aware of the authors are just plain old objects. They don't have a way of communicating back to the context every time you make some kind of a change. But the context does have its references to each of those entities, and Detect Changes is able to go and read the values and determine their state. This is going to be especially helpful to understand when you're thinking about how EF Core works in web apps where everything is disconnected. The context isn't limited to focusing on one type of change at a time, or even one type at a time. Here's a method where I'm updating an author's last name. I'm changing Josie's last name to Newfoundland, and I'm creating a new author, Dan Appleman, in the same transaction. When I call Save Changes, the context doesn't care that there's one added and one modified object. It will build and execute the needed SQL. And here's the update command, and next, the insert command in the profiler. And just being 100% sure by looking at the database, there's Josie with her new last name, Newfoundland, and Dan Appleman as the last row in the table.